Let's continue on to prelab number 10. So, why do we see light at rainbow in the sky for rains? Has to do with the fact that so white light is all colors of light, and as they move through water or whatever prism it is, so water is a prism in a rainbow, the colors get separated because they move at different velocities. So it's going to I mean, of course, the speed of light is 3.0 times 10 to the 8 meters per second in a vacuum, but depending on which material it is, that's called the diffraction, the index of refraction. It's wavelength specific. So I mean the different types of light are going to go through different speeds through the medium, and the shorter the wavelength, the higher the frequency, the more it gets bent. Basically, the slower it goes. So that's why you get purple in the bottom and red at the top. Of course, you have the double rainbow here. This is the second order. This is the first order, second order. Third order is going to be around the sun, and fourth order is going to be the double rainbow of the other one. It'll be the right order. The right order here around the sun, then it'll be that around the sun is the third and fourth order for that. But first and second orders are right there, because you might see the second order, for instance, on the with the laser. So talk about this. We talked about this in the lecture. Again, I don't want to repeat the lecture. So this really is two things here. The two things for this lab are going to use the okay. So I'll show you the apparatus setup here. Use a flashlight and laser pointer. Compact disc you must provide. I mean, you can use a Blu-ray or a DVD as well. I mean, those both have diffraction gradients on them. And does it come with a what do you call it? A flashlight. We'll see if it has a flashlight. If you don't have a flashlight, you just point it to the light, you know, kind of thing. You've seen the rainbow. Maybe you've seen the rainbow on a compact disc. It's pretty easy. Take a CD, shine a flashlight at it, or you can just hold it to a light, any light really. You'll see the rainbow. And then take that CD, Blu-ray, DVD, shine the laser pointer at it. You can see the difference in it. So record that. And then now you're gonna measure the wavelength of the laser light. So here's the apparatus. Take the laser pointer and diffraction gradient. Okay, so the idea, try and get this so it's perpendicular, you know, 9-degree angle. The way you can tell if these see, this is the primary spot right here, and then these are the second, maybe third order. These distances here, if they're the same, so this distance here, if they're the same, then you've got it 90 degrees. So tweak that around. You're going to do this with the 500 lines diffraction gradient, and you'll do it with 1,000, and you record that. So go through that. Oh yeah, don't point the laser pointer into you or anyone else's eyes. Not a good idea. So then do this, and then measure the distances there. Put through this, and same thing with the 1,000 line. Record the data and go through. So. And now laser pointer, you can do the observations, the calculations, measurement of x. So where is this? Where is the x? Sorry, where's the picture? Oh wait. So of course, so yeah, the x and the L. So diffraction gradient, x is a distance there, L is a distance there. So go back to your picture here. Distance here between this and that's your x, the laser pointer, and that primary dot. L then is this distance here or this distance here. That will do that, and then you do the equations for it, and then so the n, the number of the wavelength there, so n is so the gradient equation, and then dx divided by L. From this, you should be able to get the wavelength in millimeters. So you get your wavelength in millimeters, and divide that answer by 1,000,000 to get the, or I should say multiply it by 1,000,000. Sorry. Once you get this in millimeters, multiply it by 1,000,000 to get the nanometers. So, or divide by 1,000,000th. So once you get this lambda, multiply it by 1,000,000 and you'll get the number of nanometers. And then go through this and the laser length, and it should be red, should be a red one. And red is going to be around 700 nanometers, thereabouts. So I mean, if you do just do your calculations as best you can. If you get something that says 400 nanometers or 4,000 nanometers, you know you're wrong. Or so if you get 100 nanometers, that's going to be ultraviolet. You can't see it. If you're going to get 1,000, that's going to be infrared. You won't be able to see it. But just do the best you can. I mean, I'm more interested in the fact that you're doing the calculations more than anything else. So please again be honest and when you do this. So I want you to take a picture of this. Take a picture of your setup apparatus thing, and try and get the dots in there if you can with the picture. And if you can't, I understand. But take this picture and send it to me alongside your lab report. So let me know if you have any questions, and I will see you for Lab 11.